Okay, mastering ClickHouse schema design. So let's see some of the principles you need to learn. First of all, the smaller the data types, the less storage, fewer bytes scanned. This is good for reads. Sorting keys are the most important thing in ClickHouse because sequential access is generally 5 to 10 times faster than random access. And if you combine that with cache and compression, you can get to 40 times faster queries. For instance, if you are filtering by a column that it's not in the sorting key in your queries, ClickHouse is going to perform a full table scan. So you must take this into account. And there are some interesting specialized types, for instance, LowCardinality, that can reduce repeat string storage and speed up some operations. Storage and compression, again, sorted data compress much better. There are compact numeric types, for instance, unsigned integers that reduce disk usage and I/O. And it's very important to choose the right codecs in ClickHouse. For instance, delta encoding can dramatically shrink datetimes. Just remember, the less data on disk means cheaper storage and faster queries. There is a trade-off when designing schemas in ClickHouse. You either have to choose between flexibility or stability. Just remember that schemas in columnar databases are really hard to change for different reasons. First thing is tables are very big, and because of the design decisions of the database, they are sometimes immutable. So you need to decide on a good upfront design. Usually you want to normalize your tables, but take into account there are developer tools, some interesting developer tools that simplify the schema evolution process. So you might have the best of two worlds. You might have stable schemas, but with the flexibility of being able to evolve them as you wish. It's not that you have to optimize schemas for performance, but of course you have to take into account the semantics of your data and take into account that picking the wrong types can corrupt your results. For instance, you have to make decisions between decimal or float data types. Usually decimal are better for amount calculations. Nullable versus defaults, there is some semantical difference between them. And of course, the precision of your datetimes can also make more difficult to analyze your data depending on your date granularity. The wrong schema design can have hidden costs, especially operational costs. Remember, storage is not always cheap. Even cloud storage can be quite expensive. Of course, for slower queries, you need more cluster nodes to compensate. This is more CPU, more money. And migrations, when you have to fully rewrite huge tables, of course, can be expensive as well. ClickHouse implements a bunch of codecs to compress data. Usually configure them at database level, but there are specialized codecs you want to include in your column definition when you are designing your schemas. When talking about compression, you have to take into account three concepts, which is compression means less data transfer, so you can process more data in less time, despite of the CPU overhead you might have. There are specialized codecs, for instance, delta encoding, which is good for increasing numbers of datetimes, in which you calculate a delta, which is the difference between consecutive numbers, and this is going to give you better compression. And finally, any compression algorithm has a CPU overhead, but that's overweighted by the reduction on I/O. So whenever you can, use compression in ClickHouse. Okay, let's see an example. We're going to create another table with the same schema of the previous ones, but we're going to use delta compression plus CSTD and another compression algorithm. So we're going to see the difference between them. Okay, so we create the table and we're going to populate it with the same data, the same 100 million rows. If we look at the system columns, we can see there is a huge difference, for instance, between event time compressed with delta codec and with regular compression. We used low cardinality for the path column compared to the regular string column. And you can also compare the rest of the columns, for instance, revenue, status, or the user ID. So it's very important that you carefully evaluate your compression mechanisms so you can store less data and make your queries faster in ClickHouse. Data locality is a concept extremely important in ClickHouse, and it depends on how you design your sorting key. It's better if we take a look at some examples. We have this events row table with 100 million rows, ordered by event time, and we have a separate table which is events opt, ordered by event time and user ID. Let's see what happens when we filter by event time and user ID in events row. It's gonna do a full scan and the query is taking 300 milliseconds, but in the table that is ordered by event time and user ID, we're gonna see that it's gonna scan way less rows and it's gonna be one order of magnitude faster. But what happens if on that very same table we filter by a column that it's not in the sorting key? What we're gonna see is we're still doing a full scan and queries are slower. So this is the importance of the sorting key in ClickHouse.